Okay, guys, today we are talking about theorems about perpendicular lines. So we're going to jump right in and start off with the definition here. So the definition of the distance from a point to a line is the perpendicular segment from a line to a point. That seems pretty straightforward. But I want to show you what we mean here. So if I have a line, and then I have a point up here. If I draw another line, the only way to find the distance is if that line is perpendicular to that point. So then from the point to the point where it intersects, as long as they are perpendicular, is the distance. You can't move that in another direction and find the length there. It has to be between those two at the perpendicular. Okay, so if two lines intersect to form a linear pair of congruent angles, then the lines are blank. So what we're looking at here is that if we know that angle 1 is congruent to angle 2, if you look at your picture, then we know those two have to add up to 180, and the only way to make them add up to 180 if they're the same would be that they are 90 and 90. So that means that that forms a right angle, which means that the two lines are perpendicular. And a reminder that our symbol for perpendicular is the upside down T. So G is perpendicular to H if angle 1 and angle 2 are congruent. Okay, so this theorem says if two lines are perpendicular, then they intersect to form 4 right angles. You can see that in our picture. When we have perpendicular lines, they form right angles. So if A is perpendicular to B, then angle 1, angle 2, angle 3, and angle 4 are all right angles. Our next theorem says if two sides of two adjacent acute angles are perpendicular, then the angles are. So this says if we know that ray BA is perpendicular, so ray BA is perpendicular to ray BC, then angle 1 and angle 2 would have to form a right angle, and so our word for that is complementary. And we remember that complementary means adds up to 90 degrees. So angle 1 and angle 2 are complementary. All right, perpendicular transversal theorem says if a transversal is perpendicular to one of two parallel lines, then we know that it also has to be perpendicular to the other one. Let's go over this with an example. So I want you to notice the perpendicular transversal theorem starts off with if we know that there's a parallel line that's perpendicular to one line, then we know that it's also perpendicular to another. So this says if H and K are parallel, if you look at your picture, and we know that J is perpendicular to H, line J is perpendicular to line H, then we know that line J would have to be perpendicular to line K as well. Okay, this one's a little different. This is the lines perpendicular to a transversal theorem. They sound similar, but they're different. It says in a plane, if two lines are perpendicular to the same line, then they will be parallel to each other. So in the previous one, we started with one parallel and one perpendicular. In this one, we're saying if M is perpendicular to P and N is perpendicular to P, then we know that M has to be parallel to N. Okay, in this diagram, we know that angle 1 is congruent to angle 2. What can we conclude about A and B? Well, we talked about when we have a linear pair, which we have with angle 1 and angle 2, they have to add up to 180. And if we know they're the same, then they have to be 90 and 90. So we know that A has to be perpendicular to B. Okay, this says use the diagram to complete the following exercises. So we want to know if C is parallel to D. So if I'm looking at the picture, I want to know if line C is parallel to line D. Well, I want to look for markings. And so what I notice right away is that both of these have a right angle down here with line A. So if I have two lines perpendicular to the same line, then we know that they're parallel. So we say yes. And that theorem was lines perpendicular to a transversal theorem. When we know we have the two perpendiculars, we're proving they're parallel. Then we want to know, so we know that those are parallel. Then we want to know if B is perpendicular to D. Well, now we know that C is parallel to D, and we know that B is perpendicular to C. So, since we know those two things, then we could say that B is also perpendicular to D. So we would say yes. Now remember, these aren't the same theorems. This one is just the perpendicular transversal theorem. Okay, so kind of changing gears here. It says find the distance between two parallel lines. So in this case, we're talking railroads. It says the section of broad gauge railroad track at the right are drawn measured in inches. What is the width of the track? So the key here to know is that when we're talking distance, it has to be perpendicular. So we need to make sure that the track and the bars across the track really are perpendicular to each other. So the first thing we want to do is check out the slopes, because we know, think back to Algebra 1, that when slopes are the same, lines are parallel, but when slopes are opposite reciprocals, lines are perpendicular. So what we're looking for is the perpendicular lines here. So we want opposite reciprocal slopes. So if you don't remember your formula for slope, we use M to represent slope, and we have y2 minus y1 over x2 minus x1. So first, I'm going to find the slope of QR, since I have 2 points there. So the slope is equal to y2, so my y value is 55 for this one, and 34 for this one. So 55 minus 34 over x2 is 91, and x1 is 71. So 55 minus 34 gives me 21 over 91 minus 71 gives me 20. You can put that in your calculator real quick, see if you can reduce that. And it does not, so we just leave it as 21 over 20. So then this is telling us to find the slope of PQ next. So if I look at PQ, here's my 2 points. I have 29.74 and I have 71.34. So I want to see if those two really are perpendicular. So I'm again going to do y2, which is 34, minus y1, which is 74, over x2, which is 71, minus x1, which is 29. So 34 minus 74 gives me negative 40. And 71 minus 29 gives me 42. This one will reduce, and I end up with negative 20 over 21. So we need to compare. Are these opposite reciprocals? So 21 over 20 and negative 20 over 21. So opposite means one's positive, one's negative. So we're good there. We have the positive for our first one, we have negative for our second one. And then the reciprocal means that fraction flipped over. So 21 over 20 and 20 over 21. Those are opposite reciprocals. Those are perpendicular. Once we know perpendicular, and so it does say over here the segment PQ is perpendicular. So now we need to find the length of PQ. And to find length, we're looking at distance. Now recall that your distance formula is this big square root. We do x2 minus x1. We square it. And we have y2 minus y1. And we square it. Oh, sorry. The y2 should be down below. Let me fix that. This is a plus y2 minus y1. Put that radical back up top there. Okay, so now PQ, again, here are the points from PQ down here. So this is my x1, this is my y1, this is my x2, this is my y2. So, and I put these in here, PQ equals big square root. I have 29 and 71, and so I'm going to subtract x2 minus x1. So I'll do 71 minus 29, and I'll square it. And then I'll do my y values, 34 and 74, and I subtract them and I square. Now I do what's inside first. So 71 minus 29 was 42, and I still need to square that. And 34 minus 74 was negative 40, and I still need to square that. Okay, so 42 squared, hopefully you have your calculators, is 1,764. And 40 squared, or negative 40 squared, is going to give us a positive because it's negative times negative. So 1,600. We get the square root of 3364. Take that square root and we get 58. So the width of the track is 58 inches. All right, guys. That's all I got. I will see you in class tomorrow to finish those constructions. Have a great day.